Hello, everybody, and welcome once again to Ragmasters, a show about retrieval augmented generation and the engineers who are pioneering the field. I'm Neil Katz, a tech entrepreneur for 20 years, and with me, of course, is Daniel Warfield, computer scientist, RAG engineer in his own right, and a phenomenal educator on Medium and other places about how to build better RAG systems. Daniel, how are you?
I'm good, and I'm excited because I think this time I get to talk a lot. It's the Daniel show. We're going to be covering Agentic RAG, I believe, correct?
We are, and last week I was at a conference called the AI Engineers World Fair. I think last year was called the AI Engineers Conference. Awesome show, by the way, for AI engineers and RAG engineers who want to get into the practice. 2,000 of your closest friends, all focused on exactly the same things that you are. A lot of education, a lot of learning about, vectors and graph databases and eval systems, and our technology was in there from my level, talking about how to do better RAG. But one of the big themes, really, if I just take like step back, one of just the big themes of the show that everyone kept hitting on, or many kept hitting on, was how to build agentic systems with language models, and really specifically how to tie agentic concepts to RAG. So super timely. I'm glad we're doing this today because I was really inspired by what people were talking about this show, and I felt like now's a great time to review maybe the principles of this. The core idea is how you build these systems, what's the good, what's the bad, what the troubles you might run into, and how to build them in a really strong way. So with that, I'm going to kind of step back. I'm going to be the student here. Daniel, you're the teacher, you're the professor for this show. I'm going to jump in with questions that I think the audience will care about when needed. But mostly I'm a passenger on this cruise ship. So Captain, take us away.
All righty. So I have a slide, and it essentially has what I think a lot of sort of new people consider to be agents. This is like the layman understanding of agents. It's like you might have like a bunch of language models that are somehow working together to do something, or you might have a bunch of different things that are working together. It's a bunch of things autonomously acting cool and wearing sunglasses and wearing suits, and they're trying to solve problems. And you know what, actually, I think you'll find that a lot of these different concepts, like this is literally when I looked up agent AI and I put in Google Images, like this came up. A lot of this conceptualization to a large extent is accurate from like a really high level. You have like a bunch of self-similar systems working together, or you have a couple experts who all wear different jackets, but they kind of have a similar vibe working together, or you just have this one guy with 3 arms that's doing a bunch of different things at the same time. There's like a lot of high level concepts around RAG, but it's weird. A lot of engineers, you'd be surprised, only have that high level understanding. Like they don't really understand how it works. And we're going to try to kind of zoom in and then kind of end up where we started with this sort of like multiple different sort of personas. When I think of an agent, this is what I think of. So it's much more technical. So you have a language model, and it's basically you build some software, and it allows the language model to do some action so that it can interact with the world, and then also observe the world in some way. And then also there's an ability for it to reason about what actions it should take, and also about what observations it sees. That's like normally from like a technical perspective, kind of the high level definition of RAG. It's less so people with sunglasses on. And really, so there's 2 really core concepts. There's this ability to reason, and there's this ability to act. And before agents really came onto the scene, there were 2, I think, there were a bunch of really informative papers around this, but one of them was chain of thought prompting. So, people think like, oh, language models can think. Like, what does that really mean? What it means normally is chain of thought prompting, which is if you ask a language model a question, like, hey, what's the answer for this math problem? Right. It might give the wrong answer. It might be, there's a lot of math that needs to go in to having the right characters to be the right answer. So if it just blurts out 27, then it might be wrong. The idea of chain of thought prompting is you take the problem and you tell the model, hey, I don't want just the answer. I want you to think through the problem, right? I want you to break the problem into sections, solve those individual subsections, and then I want you to come up with the final answer at the end. And this kind of makes sense intuitively as a human, but if you understand the core inner workings of a language model, it starts making way more sense. So language models, they generate output via a process called autoregressive generation. So if you have a sequence and you say, hey, translate to French, I am a manager. So that's your input. So you're telling it what to do and you're giving it some information. Then what a language model does is it sees that and it goes, okay, I think the first output should be translation. Just to kind of, follow this format of something with a colon. Then what you do is you say, okay, language model, that was a fine prediction. Let's put that back into the input. So now your input is translate to French, I am a manager, translation colon, predict the next word. And it might be je. And then you take that word, you put it back in the input, and it might be suis. And then you take that, you put it in the input, and it might be direct there, right? So you keep passing the output back into the input to generate the next sequence. So then this kind of starts this simple concept of chain of thought prompting. It starts having this sort of emergent phenomenon where the model is coming up and learning things based on what it's outputting, right? It breaks the problem into sections and it breaks them into simpler problems. And then by breaking into simpler problems, it can get the right answer. It might be able to say 23 minus 20 equals 3. Right? Like that's relatively easy and just a single pass to figure out. So you break a bunch of these up and then you have a bunch of them in the context. So now the language model could use those for that final output, which is 9 instead of 27, right?
Yeah, it makes sense to me. I mean, step-by-step thinking is what we're talking about here. And humans, it's if you can't solve a problem up front, you should break it down into steps. And the same, oddly, is true of language models.
Exactly. So chain of thought prompting, super important, but it's not everything. So this is a big, complicated diagram from a paper called Say Can. Like imagine you put a language model, like something with chain of thought, and you stick it in like a robot, right? There's this an example. I think that's how to put something on an apple. I like to use a trash can. So my go-to example is a trash can. You tell your robot, here's this trash, throw in the trash can. And there's a language model in it that takes your words. There's probably like some sort of text or speech to text, and then you feed it to a language model. Then the language model knows I'm a robot, and someone just said I need to put something in a trash can.
Okay.
What's the next thing you should do? Then the language model might say, well, I should probably open the lid to the trash can before I, throw something away. But the issue is the robot is not near a trash can, right? So something might be linguistically plausible. Something might make sense from a linguistic perspective, but it might not be plausible in the real world, which is this architecture in particular. It aligned what a language model says should happen with what is possible in the real world to sort of align those together. And this is a fairly complex architecture. We're not going to be talking about Say Can, but this was like a really popular and exciting region of the field around when agents started to come up. And it was, how do we align language models with the real world and get them to say things and do things that make sense?
So this is, in a sense, this is a kind of a big idea in a way. You've got the language models, which are generally smart, but then you've got this infinite, this real world where infinite things can happen, and often many things can't happen depending on the place you are or the objects in the room or what have you. And so this is like a conceptual framework to try to bridge those two problems together in a way that's actually conceptually kind of simple. I think when you're about to explain it, I kind of like how this is all broken down. So I'm excited to hear you get to the next step of the probability of how Say Can actually works.
So unfortunately, I'm not going to get into Say Can too much. I do have a whole, like, it's an elegant breakdown for the alignment of the real world and a different world, but it's really from a robotics perspective. You have it's like a 2-tower network kind of. So there's like all these math details that aren't super relevant. I could go into that though. I would actually love to in maybe a future thing
for another
yeah. But really, like it's more of a conceptual inspiration. The idea of agents. You have chain of thought, which is like this reasoning loop. And then you have things like Say Can and other stuff, which is like this ability to act and observe. And then the idea of agents was really the academic community going, what if we like connect these together? Exactly. And then probably one of, if not the most influential papers in this space was the React architecture. So React is one approach. It's not the front end framework. Whenever I talk to devs, they're like, "Oh, you develop in React." It's like very, very different React. So the React architecture is reasoning and acting. And you can imagine there's an infinite ways to sort of break down this approach to thinking and acting and observing, right? But the React paper, it's a pretty rigid structure where you ask a question, then you tell the model a few things. First of all, I want you to break it into sections. And every section is I want you to think of something. So literally write out what you're going to do and what you think is important. Then I want you to put out an action. And the action is a tool, essentially. So, and then what you want the tool to do. So it might be, I want to search for the Apple remote. Then once that happens and the tool does something, I want you to make an observation that's relevant to what you thought about. So I want you to break down, if you search Google for Apple remote, you might get 1,000,000,001 pages. But what I want you to do is I want you to grab the information that's relevant to your thought. And then you do this kind of over and over and over again. And it allows a model to react based on what it previously searched, what it previously thought about, observations from the world. It allows you to do things with the world, stuff like that. And a lot of the time, there's a variety of frameworks for doing agentic things, but a lot of it under the hood is either React or something very similar.
Okay.
So what's kind of cool about this, people are like, how does RAG fit into agentic systems?
Exactly what I was going to ask you. This is great. Great segue.
I'm a professional teacher. So RAG, agentic systems are RAG. Really, fundamentally, what is retrieval augmented generation? It's you have some store of documents and you have a question about that store of documents. So you retrieve information, then you augment a prompt and you pass to a language model. So here it's one pass, but here, you're kind of doing that in a more complex way. You're having the model come up with a question. And then instead of just doing this naive augmentation generation, you're building this observation. But conceptually speaking, you're getting a language model to do RAG for you. And to a large extent, this tool is RAG.
Give it to me again, because I don't think I quite understand how the tool is RAG. I mean, give me a real world example.
Gotcha.
The real question and how this would be both React and RAG together.
Gotcha. So let's say, you're a RAG engineer and you want to build a system that can look at, 100 resumes, right? You have a document store of 100 resumes, and you're like, I want to find someone who's good at this, right? So then you say, whatever, and then you're in a RAG context, right? So you have all these resumes in your knowledge store, and then you say, hey, I want to find someone who's good at this. So then you retrieve that information, you construct an augmented prompt, you pass it to the language model, then you generate a response, right?
Okay.
So it's just RAG.
You're searching the database for people who are good at doing RAG, for example.
Exactly.
And AI search of these documents, and you find those blocks of text that say this person has RAG on their resume, this person has RAG on their resume, and this one does. You send those retrievals to the language model, and ta-da! Language model combines all those blocks of text that say Henry's good at RAG, June is good at RAG, Alice is good at RAG, and gives you an answer that combines those things together.
Yeah. Okay. So imagine if instead of the retrieval augmented generation system just being in one shot, where you ask the question and then generate a response. Imagine if that function of, hey, I want to search this thing and I want to retrieve information and I want to generate something that's relevant. Imagine if instead of it being you that does it, it's an agent that decides, I should search this RAG database and it will give me some context. And then I will make an observation that is relevant based on this thought around that context.
So in this model, so the question is asked, I'd like to find people who are good at RAG, and the React system, its thought would be, well, there's a database of resumes here, maybe we should search it. And the act is do RAG search for people good at RAG. And then the observation is what?
I saw 40 resumes that were retrieved. And I think that, and based on my thought and based on the ones that were retrieved, I think that this candidate would be particularly good. but I feel like none of the candidates are a perfect fit. So I'm going to change my search. So this actually, now I'm getting into the second thought. I think this particular candidate might be good, but they're not perfect at this thing. And then the next thought might be, well, if they're not perfect at this thing, maybe I can change what I'm searching for to find someone who's better at that particular thing. So then you do that search. And then you go, okay, cool. In the first search, so this is the third thought. In the first search, I was like, I found this and I found some people that are pretty good. In the second search, I found actually this one different person who was good in a different way. So I'm going to search another one, maybe something totally left field, whatever. And then at the end, once you feel like you found enough, you trigger a tool, which is I'm done. And yeah.
So it seems to me this is particularly useful when the task requires more than one step to be done. And RAG tends to be a one-step deal. Someone asks a question, you do a search, you provide the search results to the language model, answer is generated. But if you do something where maybe that's just the first step in a process, that's where the agentic play comes into that becomes really powerful. And that's where you might need the first search to find people that are good at RAG. You might need a second search on top of that to find people who are good at RAG and also have at least 5 years experience. You might need another search, people who are good at RAG and have 5 years experience and live within 20 miles of Chicago.
Yeah. Or like, there's a famous paper of there's a famous thing. There was a software developer who made a library like a couple of years ago, like 2 or 3 years ago, and they were trying to apply for jobs, and the requirements were 10 years of experience. And he was like, "Oh, unfortunately, I don't have 10 years of experience because I only made the library 2 years ago." So like, there's also like this robustness to it. If you ask something silly, then if the observations don't really align, then your answers, even if they're like, I couldn't find an answer, whatever. It could be, I looked at a bunch of them and I searched it a few different times. I didn't find a single person who had this much experience.
So there's some visibility to it as well. It can explain what it's done at each of those steps. So you have some benefit of understanding what actually has happened in this agentic flow.
Yeah.
In the best case scenario. Yes.
Yeah. In theory.
Get hallucination and how that can go wrong eventually in this talk. But that's how it's supposed to work.
Yes, exactly. So at the end of the day, agents love RAG. Like they're like, if you kind of understand agents, and you kind of understand RAG, you maybe don't realize how closely the technologies interrelate. But once you start kind of learning about how agents work and the way RAG works, like they're such a beautifully sort of complementary technologies that really work together. Like some people consider them as competitors, but that's not the case. Like it's like they're actually kind of the same thing, just a different, like you can even think of agents as somewhat of a different way to do RAG. You can think of RAG as a very simplified agent. They're very tightly meshed technologies.
So the way I think about it is, tell me if this meshes with you, that look, RAG is just a one kind of function in a program. RAG is basically search. You have a question, if it's contained in some database, you can search it and bring back some answers, some data, which is great. But not everything in life is search. And the things you may be asking a piece of software to do, search may be a RAG search may be a piece of that, but you might need to do other things as well. So like, here's an example from some legal work we're doing where, personal injury firms want to process medical claims. Okay, so you've got a software where if you throw 1,000 medical forms into a file and you into a RAG database, you say, find me every single patient who had heart surgery. Well, actually, RAG's not that good at it because RAG's not that good at finding every single instance of a thing. Mm-hmm. But if I had some agent in charge who could go do a RAG search and find as many heart patients as it could, and then ask itself, well, are there any more heart patients? Well, let's go do another RAG search and find out and see if we can find some other ones that don't look like these. Do we have all the RAG patients, all the heart surgery patients? Let's do another search and find out. And keep going at it in a way that add this extra layer of a program, software logic to it that pure RAG itself doesn't do. Would that be how we should think about it as developers?
Yeah, so I think absolutely, like that general sentiment. I think the next, like in 1 or 2 slides, I think I'm really going to answer that question. So agents, what's cool about agents is there's a lot you can do. So now, like we've kind of described the prototypical standard agent. but it's
Okay.
kind of interesting to play with the dimensions of this, of what an agentic system is, right? So when we talked about, this React system, we
Yep.
were using the same tool over and over and over again, right? We were using maybe it's like Bing search, I think it was in the React paper, if I recall correctly. So you do Bing search and you search for the Apple remote, and then you find it. So there's one tool called search. So this particular agent has one tool. But if you tell it, hey, instead of outputting search square bracket Apple remote, you can do find square bracket Apple remote, or you could do query database square bracket, whatever. So what's kind of cool about agents is you can have more than one tool. So if you wanted to build an agent, a system that was good at answering general questions about, people in the hiring process, you could also have a table. And you could also have a tool for aggregating results across the table, right? So if you're building an agentic system and you're heavily relying on RAG, but you sometimes want to do these aggregate sort of tasks, you could make a tool specifically for those aggregated tasks that RAG's not the best at. Then you can use the result of that tool to inform thoughts that can trigger maybe queries that a RAG system is good at, right? So that's what's kind of cool about an agent in theory, is you can add all of these robust features relatively easily simply by creating tools and linguistically explaining them so that the React agent can understand them.
Yeah. So, look, as I said, RAG search might be one thing you want to do in an application, but you might want to do lots of other things. Like maybe you want to ingest and parse documents, or maybe you want to talk to some live customer database, or maybe you want to build some charts in real time based on the things you found from the RAG search. So you would need multiple steps to accomplish a thing, and you can call each of these tools, which do different things. There's the ingest parsing thing, there's the RAG search thing, and then there's the the chart generator. All essentially different pieces of software, different systems, but all of them can be called as different tools in a sequence by an agentic system. And the magic here, I think, is from a user's perspective, they have to know none of that. And even sometimes from a developer's perspective, you don't have to preset how all of this is going to work, right? You build a basket of good tools that can do certain functions smartly, and then a user asks a question, and if everything goes well, agentic system goes, hey, what tools do I need for the job? I might need a hammer and a wrench and a screwdriver. Great. Hopefully I have those available. And then I'll call them in the right sequence until the job is done.
Yeah. To give you an example, I made a agent and I asked it, I think in my article on agents, I asked it, what's the difference between the northernmost town in the world and the southernmost town in the world?
Yeah.
And it was like, first of all, because it's a language model, it has some level of encyclopedic knowledge. So it happened to know the northernmost town and southernmost town. So it started with that. And then it was like, unfortunately, I don't have access to a geographic calculation tool for distance if I search the coordinates, I can't actually calculate the as the crow flies distance, because there's curvature of the earth, and that can be kind of complicated. So I'm going to explicitly search for that. And then it searched for it, and they're like, I couldn't find the answer. But I found a town that's 20 kilometers away. So then it searched, it was like in the south of Chile or something. I can't remember. But then it was like, let me search for the distance between these two towns. And it was like, okay, cool. That's pretty good. I found a plausible answer. So now what I'll do is I'll add however many kilometers from this other town that I found to the other town. And I'll use that as a close enough approximation for the distance between the southernmost town in the world and the northernmost town in the world. Right. And the reason it decided to do it that way was because I didn't have a tool for distance calculation. But if I had given it a tool for distance calculation, it would have chosen to approach that in a completely different way.
Right. And so one of the challenges, I guess, of agentic systems, and we're going to get into hallucination in a minute, which I think is a significant challenge, but one of the challenges is, can it pick the right tool? And you'd think that if you just gave it a library of millions of tools, well, this would be great. But that's not often great, right? You have to sometimes limit its choices of which tools are available, or that first step itself can go awry. My understanding is agentic systems aren't good at, I have infinite tools, let me pick one. It might be better at, I have 5 or 6 or 10, let me pick one.
So this is actually, we're touching on a fascinating application of RAG in an agentic context that a lot of people don't know about, and I don't hear talked about frequently. So like, you can have more than one tool. This is an excerpt, or this is a screenshot from WebGPT when ChatGPT went online and everyone was freaking out about it a couple of years ago. This was the paper that kind of sparked a lot of that. And they made, a bunch of tools for interfacing with the web, right? So the agent could say, I want to scroll up or scroll down or click stuff or whatever, right? You can have a lot of tools. Oh, sorry. So let me actually skip ahead because I have a lot of stuff I want to talk about, but I think this is immediately relevant to what we're discussing. You can have a lot of tools if you want, right? And like, imagine if you're Google and you're trying to implement Gemini into all of the products that they have, right? So a vast number of tools, like kind of an absurd number of tools, right? What you can kind of do is, if you can't tell the agent about all your tools, you can have the agent request a type of tool that it might want and then get back that tool, which can be done with RAG. So not only are the tools themselves RAG, you can build a retrieval engine for retrieving tools that are described textually.
Yep.
And then when an agent says, when the agent thinks, I would like to do something, but I'm not sure which tool I need, you can embed that as a vector or in some other, sort of RAG context. Then you can query your database of all of your tools, and then you can get back a list of the most relevant tools for that thought. And then you can tell the language model, these tools would probably work. So why don't you pick from this subset of tools? Then the agent can go, I think this one makes sense.
I like that so much because, RAG at its core is like trying to whittle things down. It's like the whole reason RAG is because you can't just give infinite things at once to a language model. So you're trying to whittle down of, millions of documents or millions of chunks of information, which one should RAG, which one should be sent to a language model. It's really the same idea here, right? You've got too many tools. You call a RAG search, you whittle it down, you find a couple of great tools, and RAG search sends that back to the agent, which goes on its way to then figure out which tool to call.
Yeah.
Here's 10 tools that you. The agent then has to make a decision with the language model. Of those 10, which one do I like? And pick one and move.
Yeah, which is kind of a bonkers approach to agents. And really, like, that's the type of thing that's only really practical in a massive scale, right? When you're trying to build agents that are trying to navigate incredibly complex environments in massive companies, and you're trying to build an integrated solution around that. There are kind of subsets of that. So let me scrub back into the past.
Then I want to make sure we get to hallucination, because I think it's a big topic with agents where people have struggled to build agentic systems. It's one of the hurdles in building really good production-ready agentic systems. So make your point, and then I'd love to get to the hallucination issue and what people can do to try to ameliorate the problem.
Yeah, I think I can just kill the rest of the slides really quickly. So like, a lot of people think you have to choose one, RAG approach. If you have an agentic system and you have a variety of things that you're trying to align together, in theory, you can use multiple RAG approaches. Also, within one RAG approach, you can subdivide your problem into different RAG approaches and frame them as different tools. And also, if you find that some approach works well in some applications, you can do both of those. So you can subdivide your problem into different things, and then you can optimize them individually with different RAG approaches or different advanced strategies or whatever. Also, so our RAG approach, we build a RAG approach, a retrieval approach specifically. We have this idea of a project that, can sort of point to buckets. And I've been talking about this a lot with prospective customers.
Sure.
This sort of project, you can programmatically change which stores of documents it points to. And like, naively, that's for like, if you have a specific project and then you say, okay, this project relates with this store of documents, this project relates to this store of documents, but you can kind of hack the system. So if you have a project that can be updated to point to different stores of documents, you can make a tool that an agent can use to say, which things should I be looking at across all of the things for a particular query. So that could be 4, 5, 6 stores of information that are all relevant to this thing. And then you get rid of the noise from the things that aren't relevant. And then let me retrieve against that subset of things.
Or let's imagine each bucket has different security requirements to it. And this agentic system, someone asks a question, agentic router can say, okay, this person has clearance for A, B, and C, but not D, E, and F. Let me go find bucket. I wonder which buckets have A, B, and C clearance. Let me go do search on those.
Absolutely.
Yeah.
Yeah.
It's something we hear a lot actually at eye level at like doing RAG in the real world, which is people inside a company. Yeah, great. You're going to build me a question and answer machine that can answer any question about any question inside my company. That's great. I've fed it 100 million pages of documents. Okay, that's interesting. But in reality, the CEO has the rights to a very different amount of information than the VP or the local director or whatever. And so how do you create data security and rules within these language model systems? And so this is a very helpful approach.
Yeah. So I've built agents that are more locked in than this. I have an article that I wrote called Conversations as Directed Graphs, where like you can force certain things to be programmatic, right? Like if you kind of make your own agent and you really get into the weeds of how it functions, you can have this flexibility and also lock down certain security things. And you can kind of play with the amount that the agent is allowed to decide and what is programmatically defined, partly by the definition of the tools, also with parsing strategies and stuff like that. So that's my TED Talk on React. I would love to talk about hallucination. I don't know if you want me to take a stab at it or if you want to get that ball rolling.
Well, I'll get it just rolling with, something I've heard a lot from people in the field is that, okay, this agentic approach is really interesting. It sounds kind of like a Swiss Army knife. That's great. So I've got my little special agents. Maybe the agents are even talking to each other. You could have systems where a bunch of agents are floating around. They talk to each other to ask and do things. But because we know language model applications can hallucinate, if one of these agents who's tasked with one thing over here hallucinates and starts to talk to another agent tasked with another job, now they're just basically having a shared hallucination. They're just tripping in some like at a dead show, whatever. They're just like basically talking nonsense to each other in some recursive manner. And that can happen pretty quickly and go down a bad stream. So you've got a bunch of agents basically gone mad from talking to each other because one had a hallucination. Whereas with human beings, it's not quite like that. If you come down the street and you're tripping out and you're saying crazy stuff, everyone goes, wait a second, that guy's saying crazy stuff. I have a filter against that. You're not going to influence me to start saying crazy stuff. What happens in these agentic systems? Do they snowball if one makes a mistake and sends the other into a tailspin, or are there ways to deal with that?
Yeah, they totally do. So we're getting back down to reality here. We talked about all this cool stuff, very exciting, super interesting, but behind there's an inverse correlation with cool and verifiable. The cooler things get, the harder it is to verify if they work. Okay. And that seems like it's like the Moore's law of productizing AI. That's the reality, right? So I would say if you don't need all this fancy stuff, don't do it. If you just need RAG for your application and you can wrap that in a very small sort of application layer that maybe allows for some amount of like keyword parsing or something, so you trigger some different stuff, whatever, do that. If you can lock it in and you're really serious about making money, you're not just playing around with technology, do that, because it's falsifiable and it's verifiable. It's easy to configure. If you need an agentic system, if you really need an agentic system, the verification process of an agentic system is the same as the verification of RAG, but way harder because now it's also wrapped around in an agent, right? So you can still have the core RAG that fails, and then you can also have the agent that fails, and it can fail in terms of how it thinks. It can fail in terms of how it, does it structure the tool execution effectively? Like that can just break. Does it make observations that are meaningful and relevant? Does it properly contextualize stuff? Do I have enough tools? Do I have to build a tool for this? Oh, no, I have to validate that tool. It can snowball really quickly, right? Yeah. And the fact of the matter is, I don't think that anyone knows and has a silver bullet for making an agentic system. You can't just, there's no nice little bow perfect agent for my application. That's not how it works, right? It's a lot of effort, and the more complex it gets, the more effort you need to put in to make sure that it is consistent.
These are still a kind of frontier approach. This is still maybe more experimental than in production in the real world. but has great promise if we could figure out observability and evaluation literally in real time as it's happening.
Well, so in some ways, it depends on who you ask, right? Call centers, there's been some call center applications that are kind of scary good at traversing, the standard sort of call center script where you have like a graph, and then basically they build an agent that kind of goes through, and then it has text to speech and speech to text, kind of on top. So in some use cases, agents have been ludicrously effective, and they already are in production, and they're creating massive companies. In other applications that maybe aren't so perfect, agents can struggle, right? So it's a lot of it. It's a classic design problem, right? You have a technology. You need to understand it, right? So when you get to the point of understanding it and you intimately understand its constraints, then you go, how can I frame my product such that it maximizes the utility while minimizing the risk of this particular technology? So I would say that agents are ready for productation now. I'd say they've been ready for productation for a while. Really, it's a problem of design, and because it's a whole different ballgame. It's not just ones and zeros, and it's like it can be wrong. Like it takes a lot of creativity, and it takes a lot of knowing the intricacies, but also being able to think about the bigger picture. I think that's really the biggest problem, maybe actually in all of AI right now, is what do we do with this crazy fast car that we just got? I don't know how to drive it. What is this weird button on the steering wheel? I drive a Ford Fiesta. You know what I mean? I think that's really practically actually where it kind of is right now.
I think that's a great closing note to end this particular show. On the next episode, Daniel tries to figure out how to drive AI without crashing the car. Thank you, man. That was an awesome introduction to Agentic Rag. And we'll see you guys next time on Ragmasters. Thanks a lot.